calculus. Alright, this is my tutorial. We're starting with problem 1. First question, identify this as a growth or decay equation. So the way that we tell if it's a growth or decay equation is what the b value is. So it goes a, b to the power of t equals p of t. So that's this equation. It's a little not neat. So if the b value is in between 0 and 1, then it is a decay equation. So this is decay because 0.71 is in between 0 and 1. Next question on b, what is the factor? The factor is just the b value, so that's just 0.71. Next question, what is the rate? So normally how you find the rate is the x in this equation. So all we gotta do is subtract 1 from both sides. Hold on. If we subtract 1 from both sides, we get x is equal to 0.29. So that is, and then we have to convert it into a percentage, so it's 29%. So that would be C. Now for D, if you start with 400 milligrams of ibuprofen, how much is left after 3 hours? Okay, so let's first set up the equation. So the equation would be, we'd start with the initial value, which is 400. We have the factor right here, and then we have the time right here. So this is really easy. We just got to plug this into our calculator. So I'm going to do that now. 0.71 cubed is 0.36 rounded. So 400 times that would be about 143.16. So that's how many milligrams would be left, and this makes sense because this is a decay equation. Alright, yeah. Let's erase this. How long would it take for there to be 50 milligrams left in the system? So this one's a little bit different. We have to solve for t, which is up there. So the initial value, I believe the initial value is still 400 since we're solving for t. This would be 0.71. This would be t. So then what we can do is we can divide 400 by both sides, and on the left side we'd have 0.125 is equal to 0.71 to t. Now to get to solve for t and get it down from the exponent position, we can log both sides. Now that we've logged that, we can move the t here. So let's just do that. And let's put parentheses around it so we know it's its own thing. Now, I'm running out of space here, so I'm just going to draw an arrow to right here. So now we can divide both sides by log 0.71. It's hard to tell. Log 0.71. So over here, we'll clean it up. We have t equals log 0.125 over log 0.71. Now if we solve that, we will get, one second, we should get 6.07, which this would be in hours, so 0.67, or 6.07 hours would be your answer. All right, now problem 2. All right, going ahead to problem 2, we need to find out which of these two scenarios are more profitable. So starting with A, we need to set up an equation that's compounded quarterly. So how this would look is we have our initial investment. Well, first we need to put down, this will be what we're shooting for in money, and we're trying to find how fast we're getting to that money, so we're solving for t. So the equation, let me just finish writing out the equation. The initial value would be 1,500, and then we have 1 plus the rate of 0.25 over 4, because that's how many times it's being compounded a year. Then we have 4 again, and then t, 4 years, because that's determining how many times it's compounded. So that's what that would look like. So now that we have that equation set up, let's set up the next one, and then we can solve them both in a second. So for this one, again, we want the end value to be $2,175, and the initial value is $1,500. But what's different about this one is that this is the PERT one, so we gotta have the E. The rate here be 0.024, and then we just have to put T right here. So both of these we're going to be solving for T. So let's start with the first one. The first one, we want to get this divided by both sides, because that's an easy one. So divide both sides by 1,500, and let's move this right over here. Let's move this right over here. So now, if you did that, you would have 1.45 is equivalent to 1 plus 0.025 over 4 to 4t. So that'd be your equation. So now, and we can solve this real quick. So 0.025 divided by 4 plus 1 would be 1.00625. And this is to 4t equals 1.45. So similar to the last one, we can use logarithms to get the 4t down. So what we can do log to both sides. We'll add parentheses to make it clear. And then we can move the 4t down. So now it's 4t, we'll parentheses it, log 1.00625 equals log 1.45. Now we can divide both sides by this number right here, log 1.00625. And what this will do is isolate the 4t. So now we're left with log 1.45 over log 1.6 or 1.00625 is equal to 4t. So let's just plug this into our calculator real quick and see what it equals. So if we do that, you would get 59.64. 59.64. How do I set up? 0.64 equals 4t. So now we just divide both sides by 4. And by the way, we're going for the smaller number for t. So once we get both the a and b, whichever has the smallest, t will win. So this comes out to be 14.91 equals t. So that's our answer, 14.91. So let's erase all this real quick. And so 14.91 is our first answer. And then we're going to do B next. So now that we've erased all that, we have 14.91 equals t. So we're going for a lower value. So now we have to solve on this side. So this one, again, divide both sides by 1,500, 1,500, and we'll move it over here. Let's add a line to divide both sides. Let's clean this up. All right. If we move it over here, so again, that value when 2,175 is divided by 1,500, it equals 1.45, which is equal to e.024t. So how we can get this down is by using natural logarithm, since the base is e. So we can do ln 1.45 equals 0.024t. And then now all we have to do to isolate t is divide both sides by 0.024024. And so now if we solve for, if we plug this in, because it does equal t, ln 1.45 divided by 0.024. So that gets you 15.48, I guess years. Or I guess equals t. So it looks like the top equation won. So the one that was compounded quarterly instead of continuously. Next we have problem 3. So this one starts out by identifying if it's a growth or decay equation. So if you remember from problem 1, the way we figured out whether if it's a growth or decay is by using the b value. So a b to x equals f of x or y in this situation. So that's actually horribly drawn. So the b value here is greater than 1, which means it's a growth equation. So growth. Now what's the rate? So 1 plus 1 plus x equals 1.17. So x equals 0.17 times 100 equals 17%. That's our rate. C. What is the factor? That's obviously just the b value, as we discussed earlier, just right here. And d, now we just got to plug in the equation. So if we plug this in, we have 0.25 is multiplied by that, and then x equals 5, as it says. Find the value of y when x equals 5. So we do that. Now if we solve for that, 1.17 to the 5th power is 2.19. And if we multiply that by 2.25, y ends up equaling 0.548. So that's what we're going to put there. And x is in years. This is 5 years. So I guess y is in milligrams. So we got to put that down too. All right. So now we're on E. Let's just erase this one. So now instead of solving for y, we're going to be solving for x, and we're going to be given y. So here, y equals 0.88 milligrams. So we want to do 0.88. Right, let's move this up. 0.88 is equal to 0.25, 1.17 to the power of x. So now we just need to find x. So how we do that is we got to divide both sides by 0.25. So then after we do that, 0.88 divided by 0.25, it equals 3.52 equals 1.17 to the power of x. So now that we have this, to get it down, we can log both sides. So log 3.52 is equal to log 1.17 to the power of x. And then we can move x down there. So now it's x log 1.17 is equal to log 3.52. Now if we divide both sides by this log value right here, then we will isolate x. So now if we move over here, we have log 3.52 over log 1.17 equals x. So now if we just type that into our calculator, we will get 8.02. And this is in years because we're solving for x. So that's our answer. So we can do 8.02 years. Alright, problem 4. So starting with A, we need to make a function for a population that's decreasing at a rate of 1.27% per year, and there are 93 animals in the habitat you are studying. So to make this, we have to do population function equal to, and this is the normal equation, but if we're applying it to this example, we're going to have p of x equal the initial value, which is 93, and then the rate is decreasing, so we need to do 1 minus 0.127, and that will equal 0.9873. So it's 0.9873 to x, which is time in years. So we're going to apply this in B. Find when the species will be under 65 animals. So if we're applying this, it's going to be 65 must be greater than the amount of animals that actually exist. So this will be 93.9873 to the power of x, because that's what we're finding. That's the time. So to start off, we can divide both sides by 93. So 65 divided by 93 equals 0.70. So now we have 0.9873 to x. And the way we can isolate x is by using logarithms. So we have log 0.70 log 0.9873. If we log both sides, it works out. So now we can move the x down over here. So we have x log 0.9873 log 0.70. And to isolate x, we can divide both sides by this number right here, log 0.9873 log 0.9873. So Now that we've done that, we should end up with log 0.70 over log 0.9873. This is not equaling. This is greater than x. So if we plug that into our calculator, we will get, all right, what that means is it'll be 27.91 years until the species will be under 65 animals. So we can write that over here. All right, so for C, we just have to plug in 12 for x, because it says how many animals will there be after 12 years. So using this equation up top at the A right here, we could do P of x equals 93.9873 to the power of 12. Now if we solve that 0.9873 to the power of 12, it equals about 0.86. And so 0.86 times 93, that would equal 79.78. So that's how many animals. Well, we obviously can't have a fraction of an animal actually. So we probably need to round down, or actually round up. So there'd be 80 animals, or 79, I don't know. 80 animals. So that will be our final answer.